Okay, so in this video I want to look at the three-dimensional coordinate system, the Cartesian coordinate system. So we're used to the two-dimensional coordinate system, but we're going to look at three dimensions. Three-dimensional coordinate system. And sometimes this is referred to as R3 or R cubed because in two dimensions, if we look at 2D, ordered pairs are represented by x comma y in a Cartesian coordinate system, a rectangular system, where we have an x coordinate and a y coordinate. We get two values, two real numbers. So that's also called R2 or R squared, okay? So when we go to three dimensions, we use ordered pairs that are x, y, z. And so that's what we're going to focus on here, is how do we represent this three-dimensional coordinate system, R3. So the first thing is, how do we draw an x-axis, a y-axis, and a z-axis? How do we draw three dimensions on this two-dimensional flat board? Well, here's sort of the progression that you want to think about. So if we look at the traditional xy R2 plane, the positive x-axis points to the right, and the positive y-axis points up. And I won't draw the negative axes for now. So one standard approach to create a three-dimensional coordinate system using x and y is to make these, instead of being a vertical plane, to tilt them back and lay them flat so that it's a flat plane. And so one way we can do that is simply to tilt the y-axis back like this, and maybe it points back this way. So now our positive y-axis points that way, our positive x-axis is this way, and it's more like laying down the floor. In fact, I can increase this angle to such a point, maybe something like that makes it look better. And this is still the right angle in this new perspective. I'm not great at drawing that, so that right angle is still this right angle. Okay. Now that presents maybe it's fine the way it is, but it's common to not want the positive axis to point back into the wall. So what we'll do is we'll rotate this guy around so that now when we do this, the positive x-axis is going to be pointing, it's still laying flat on the floor, but it's pointing out of the board. So there's our positive x-axis. And now our positive y-axis is going to rotate to the right pointing direction to look something like this. So now that's our positive y-axis, and now this is that same right angle. And so this is the standard that I'm going to follow for this particular video. So this is our two-dimensional, this is R2 in three dimensions. Think of it as the floor of a three-dimensional space. And so the positive z-axis, which we will now attach to this, because that didn't exist before, we will run it perpendicular to this x and y axes. And of course, so that angle there is a 90 degree. And if you imagine this origin now, where x, y, and z are 0, the origin is like the corner, the bottom corner of a three-dimensional room, where the wall meets the corners of the floor. Okay? So that's R3. That's what we'll be looking at. So the positive x-axis is coming out of the board. The positive y-axis is to the right. The positive z-axis is up. So in summary, the x tells us forward, which is out of the board, or backward into the board. Okay? Out or in. Write this down however you like. Out or in. So the positive direction is out of the board, which I'm going to call forward. And the negative direction is backward. going into the board, okay? That's tricky for a while. You have to practice with that. The y-coordinate tells you positive is to the right, negative is to the left. So that's pretty easy. So positive is right, negative is left, okay? And finally, z, the z-coordinate, positive is up, negative is down. All right? So there we go. And just so you understand, if you do plot some point in 3 dimensions in R3, that's what this is, remember this is R3. If you plot some point here now, it's a little bit harder to show where that point is because it's not clear how far forward or backwards it is and things like that. But I'm not going to get into plotting the points in this particular video. I just want to introduce you to the system. But this point now is represented by an x, a y, and a z. And if there were 2 values, we would call this an ordered pair. Ordered because x and y are in that same order every time. When we attach a z, it's still ordered because x, y, and z come in that order. But now instead of a pair, we call it a triple. So this is what we call an ordered triple. Points in 3 dimensions, ordered triples. Okay? So that's the introduction to the 3-dimensional coordinate system, otherwise known as R3.